Over the decades, air travel has continually increased. Managing the flow of air traffic into and out of major airports had always been an important issue. But by 1968, air traffic had increased to the point where modifications had to be made to accommodate the growth. Specifically, air traffic in an area bounded by Chicago, New York, and Boston had reached unacceptable levels.
At the heart of this Golden Triangle area was John F. Kennedy Airport in New York City, the major contributor to the problem. Equipment outages were frequent and holding stacks were becoming unmanageable. This dilemma caused New York Center to place restrictions on traffic inbound from Cleveland and Washington centers. These facilities in turn passed their own restrictions onto Chicago Center, thus creating a domino effect. Such restrictions imposed by individual facilities to protect their airspace impeded the traffic flow instead of improving it. This caused delays throughout the Golden Triangle. The traffic congestion problem at JFK Airport created the need for several studies of air traffic within the Golden Triangle. The studies concluded that it was no longer feasible for each center to develop flow control procedures independently. It was determined that central flow control and direction was needed.
On October 6, 1969, the newly created Central Flow Control Facility began working on solutions to the air traffic delays into JFK and the domino effect this congestion created. The answer was rerouting certain flights around the busier sectors across the country. This procedure delivered the aircraft to the JFK area in a manageable fashion. Then, in the early 1970s, the energy crisis caused a rapid increase in fuel prices. Conservation measures were imposed on the air transportation system. A conservation program known as Fuel Advisory Departure, or FAD, called for minimum airborne holding at destinations. Instead, flights were held on the ground prior to takeoff until a slot for their departure was received. These became known as ground delay programs.
Hey, this is Howard at the System Command Center. We're coming out with a JFK ground delay program, 2000 through 2359Z, due to low ceilings and visibility.
By 1981, the year of the air traffic controllers strike, these ground delay programs had been implemented nationwide. They were a major contributor to the continued flow of traffic, despite the severe reduction in air traffic controller resources. In 1990, the Central Flow Control Facility was renamed the Air Traffic Control System Command Center, or ATC-SCC. This new name better reflected its mission. And in 1992, the organization moved into a new facility in suburban Virginia built specifically for traffic management purposes. Today, this modern facility provides a central coordination point, a focus for all national traffic management operations. The goal of the command center is to balance the available capacity of the air traffic control system with the existing and projected demand. This should be accomplished while minimizing delays to individual aircraft.
It's the role of the command center to solicit and coordinate capacity information from facilities all around the U.S. and Canada.
Cleveland ground, okay.
This information is then compared to the anticipated demand from the users, the airlines, the cargo carriers, the military, and others. With the assistance of those same users, problem areas are identified. Once the trouble spots are highlighted, strategies are developed to minimize the impact of those problems on the aircraft operating within the system. This process, called MIME, for Minimize Impact, Maximize Efficiency, is the key to coping with the inevitable problems that can occur within this complex system of air traffic control. Minimizing impact and maximizing efficiency is a difficult job, especially with traffic levels increasing. Traffic management administrators at the command center handle capacity problems every day during their early morning meeting. During this meeting, the previous day's activities are discussed, including any problems that were encountered. Lessons learned are defined, as well as assignments for situations requiring further investigation. At the conclusion of this meeting, the current system-wide situation is discussed, along with any anticipated problem areas for that day, such as weather or equipment outages.
The Air Traffic Control System Command Center oversees air traffic nationwide. It monitors actions taken by traffic management units, or TMUs, at airports and en route centers across the country. Traffic Management Coordinators, or TMCs, in each center's TMU are responsible for the management of traffic problems within their area. Terminal TMCs manage problems specific to the terminals under their control. They determine the capacity of their airport, meaning the number of aircraft that can arrive or depart during a given time period. Center and terminal TMCs review traffic loads and coordinate implementation of traffic management programs for their respective areas with the command center.
Because of the complex nature of the traffic management system, each specialist, whether center, terminal, or command center, must understand the interdependence of each system component. Each specialist relies on the other for the effective and efficient operation of the system. As a rule, we do an excellent job of managing traffic flows. However, when traffic demand exceeds system capacity, traffic management programs must be implemented. Miles in trail, minutes in trail, and altitude restrictions are some of the tools used to ensure the safe and orderly movement of air traffic while reducing sector and airport saturation. The overall goal is to minimize impact and maximize efficiency.
There are several other types of traffic management programs used to regulate an aircraft during the departure, en route, and arrival phases of flight. All are designed to achieve optimum use of the national airspace system and minimize the effect of air traffic delays on the flying public without increasing controller workload. Departure flow management ensures an orderly flow of traffic from the terminal environment to the en route environment. This management includes ground delay programs, which hold aircraft on the ground to limit airborne holding, and ground stops, which impose an immediate constraint on system demand.
En route flow management regulates traffic flows in the en route environment. The en route spacing program helps controllers achieve desired spacing of aircraft to ensure optimum traffic levels. The North American Route Program, or NRP, allows users increased flexibility in flight plan filing. The Severe Weather Avoidance Plan can reduce restrictions on coordination and traffic management when rerouting aircraft around areas of severe weather.
Arrival flow management allows aircraft to absorb arrival delays during the en route phase of flight. The Arrival Sequencing Program delivers arrivals from the center to the terminal in a pre-planned sequence. Special traffic management programs are established when a location is required to accommodate above normal traffic demands, for example, during the Super Bowl or the Indianapolis 500.
Today, the Enhanced Traffic Management System, or ETMS, assists traffic managers in coping with ever-increasing levels of air traffic. ETMS is in place at all major facilities and provides traffic managers with specific data on aircraft demand. This data includes graphic depiction of aircraft positions, along with the direction of flight, altitude, and other flight plan information. It also provides tabular information such as graphs, charts, and summaries of aircraft data.
The Monitor Alert function of the ETMS provides traffic managers with both graphic and tabular information on airports and airspace approaching their capacity limits. By providing this information in advance, traffic managers can anticipate problem areas and take action to minimize impact. The ETMS also provides other tools that help traffic managers route aircraft around trouble spots. For instance, they can delay aircraft on the ground when absolutely necessary and keep them informed about the latest changes to the traffic management system.
FAA Traffic Management is constantly developing new strategies and tools to minimize impact and maximize efficiency of the traffic management system.
Only through an aggressive use of technology and a never-ending search for efficiency can traffic management hope to compete with the demand for access to the air traffic system.
The role of traffic management and its importance to our air traffic system is unparalleled in the history of the FAA. With each new day, we see an increase in demand. Previous ways of doing business are as outdated as the 707. Both systems performed their job well, but like the 707, our system became inadequate to deal with the increased demand. The need to use more sophisticated technologies was paramount. Today, with the changes that have occurred, we can no longer operate as we did in the past. We must recognize the dependence each of us has on every other member of the traffic management system. We must recognize that our decisions on the local level have far-reaching consequences. And we must recognize that every person who buys a ticket or files a flight plan is relying on each of us to get it right. We must do everything in our power to make this system as safe and as efficient as possible. Only by working together can we achieve this task of managing the flow.